Alright guys, in today's lecture we'll talk about factoring expressions and greatest common factors. So let's begin. Alright guys, the first thing is more or less picking up on a skill that will help us factor quadratics and factoring trinomials. Sometimes we can factor numbers where if I looked at this column here, this might represent B in a quadratic equation, and this column here might represent numbers that would be a C. Now I want to separate these. These are all different problems here. Okay. The goal is to just get you thinking about factors of numbers. Okay, this side's going to be more or less your factors. Factors of C that will add to give me B. So like in this example, the top example here, two numbers that multiply to give me 40, and those same two factors have to multiply to give me 14. Well, guys, it takes practice, but two numbers that pop up in my brain is 10 and 4. 10 times 4 is 40. Is 10 plus 4 equal to 14? Absolutely. So I just solved that problem there. The same thing. Two numbers that multiply to give me 15. And at the same time, they had to give me 8. Well, the first two factors that come up in my brain is 3 and 5. 3 times 5 is 15. Does this add up to give me 8? Absolutely. Now, you're probably thinking, wow, if it's that simple. Sometimes it's not, especially when you get negatives thrown into the mix. Like, here's a negative, and here's a negative. I still always go back to, well, name two numbers that multiply to give me 35. And I'm not worried about negatives just yet. The first thing that comes to mind is 7 and 5. One of these guys has to be negative. If I put 7 and 5 over here, I know I can get an answer of 2 somehow, negative 2. But here's the key point. If this is negative, if B is negative and C is negative, in this case that's true, the larger number must be negative. Okay? One of these guys has to be negative. Because when you multiply two numbers and you have a negative answer, one of them had to be negative. But if you add them and the answer is negative, it goes back to adding and subtracting integers. Negative 2, since our answer is negative, our larger number must be negative. Now, what if C is positive and B is negative? Well, if that's the case, I know 4 times 2 is 8, and somehow I can do something with 4 and 2 to make 6. But in this case, it's negative 6. Sometimes the sum is negative and the answer is positive, but if that's the case, both numbers have to be negative. Because a negative times a negative equals a positive. Alright? Alright guys, example 2. This is more or less finding the greatest common factor. Okay, GCF. Also known as GCD, greatest common divisor. I call it that just because, well, you might have a greatest common factor of 4 between these three numbers, but 4 is not a greatest common divisor of 6. Alright? So we got to find that number that divides all 4 of these numbers here, the coefficients in this expression. Alright, so my GCF is what I'm going to find, And I'm going to write right here. It's part of its own answer. Well, I know 4 would work, and I keep focusing on 4 because 4 could be the number. But you have to ask yourself, does 4 divide 8? Yes. Does 4 divide 12? Yes. Does 4 divide 6 evenly? No. It'll divide it, but it won't be pretty. So 4 is not the answer. So what does that mean? Well, let's think of factors of 4. We got 1 and 4, and 2 times 2. Well, let's find the next best factor that we got. Well, factors of 4 are 1, 2, and 4. We've already ixnayed 4. 2 is the next best thing that we got. Well, I know 2 divides any even number. 2 divides 4 evenly. 2 divides 8. 2 divides 12 perfectly. 2 divides 6 perfectly. That's about all I got. So I took care of the number. I found the greatest common factor of all 4 of those numbers. The next thing is, what about the variables? You got to ask yourself, does each term have a variable in it? Yes, the variable's m. What is the largest exponent? Or not largest, smallest exponent on the variable? 2. That's the one that we factor out. Okay? The greatest common factor of your variables as far as exponents cannot be bigger than the smallest exponent. Alright? Now I found the greatest common factor. What do we do with the rest? Well, what we're going to do, I'm cleaning this up here, is take each term from the original problem and divide it, greatest common divisor, by that greatest common divisor. So 4 divided by 2 is 2. Now right here, if you take that and you're dividing, let's go to the side here. M to the 5th, and I want to divide that by m squared. Well, if I expand this out, I have this. Cancel, cancel, what's left? M to the 3rd. Now, you got to remember your rules of exponents. When you're dividing, it's basically just subtracting the exponents. Okay? So, 5 minus 2 would be 3. Alright? So, this is going to be m to the 3rd. Bring down the sign, plus 8 divided by 2 is 4. Subtract my exponents, I got m squared left. Plus, bring down the sign, 12 divided by 2 is 6. Subtract the exponents here, 3 minus 2, that is 1. Bring down the sign, plus 6 divided by 2 is 3. And I took m squared out. 2 minus 2 is 0. I'm good there. So my answer is right here. Alright. Well, boys and girls, that's all for today. I will see you later.